Let's move towards the place value and face value. Here is the definition of face value and place value. And the definition is face value is the actual value of a digit. It means that the face value is the value of the digit in a number. As we know that every number has a digit, then the face value of a digit in a number is the value of the digit itself. This value is same wherever it is placed in a number. For example, in number 7945, the face value of 9 is 9. Let's move towards the place value. And the definition is the value of a digit based on its position or place in the given number. And also, place value is the value of each digit in a number. If we have to find place value of a digit, then the formula is equal to face value multiplied by position value. Here is the example of the number 7945. Students, in this example, the face value of digit 5 is 5 and 4 is 4 and 9 is 9 and 7 is 7. And the place value means position value of the digit 5 is ones and 4 is tens and 9 is hundreds and 7 is thousand. So by multiplying face value and position value, we get the place value of digit 5 is 5 and the place value of digit 4 is 40 and place value of digit 9 is 900, and also for the digit 7 the place value is 7000, as their places are ones, tens, hundreds and thousands. Students, here is the example of face value, that is 63,215, and we can see that the face value of digit 5 is 5 and 1 is 1, for 2 is 2 and 3 is 3, and the face value of digit 6 is also itself 6. Hence we can see that here is an example of place value, that is 4,53,169, and we can see that the place value of 9 is ones and place value of 6 is tens, place value of 1 is hundreds, place value of 3 is thousands, place value of 5 is 10,000 and place value of 4 is lakh. According to their place values, tens, ones, hundreds, thousand, 10,000 and lakh, the zeros are mentioned. Let's see a combined example of place value and face value. Each digit in a number has a place value and a face value. Students, you can see that in the number 3789, the digit 7 is in the hundreds place. The number you can see is 7. This means the digit 7 in the number 3789 is 700, as its place value is hundreds. Students, in the given boxes we can see that in 3789 the face value of 7 is 7, but the place value of 7 is hundreds. This is a difference between face value and place value. Place value just show the position of the digit and face value is the digit itself. Let's take a clear difference from this example. As you can see here, the number is 3679. We can see here the face value and place value both. Students, the face value of these digits is itself. Like the face value of digit 3 is 3 and for 6 is 6 and for 7 is 7 and for 9 is 9. And now for place value, we can see that the place value of digit 9 is ones and the place value of digit 7 is tens. Also place value of digit 6 is hundreds and place value of digit 3 is thousand. Also students, you all get clear the difference between face value and place value. Now have a concept about periods. Students, if the numbers are very large, rating them can be quite difficult obviously. In order to simplify this type of matter, numbers are grouped according to the place values called periods. Here is the definition of period. We can see here a 3-digit grouping of a number on a place value chart that represent its value is called period. Students, we can see here is a table just above the definition. There are 3 groups in this table: units, thousand and millions. And their subgroups are also 3. In the unit, we can see their subgroups are ones, tens and hundreds. And also in group thousand, we can see their subgroups are thousand, 10,000 and 100,000. And in group millions, we can see their subgroups millions, 10 millions and 100 millions. Students, these 3 groups makes our work easy to understand the numbers. Friends, let's have a concept about expanded notation. Here is an example of 5468. We can see here the place value of 8 is ones and 6 is tens, and place value of 4 is hundreds, and also place value of 5 is thousand. In order to write the place value of the digit in a number, we will write it as in descending order using plus sign between them, as you can see here. Here we can see that place value of 8 is 1, so 8 multiplied by 1. And place value of 6 is 10, so 6 multiplied by 10. Place value of 4 is hundreds and 4 multiplied by 100. And also place value of 5 is 1000, so 5 multiplied by 1000. And now adding these values shows the expanded notation. Now start to solve exercise 2b, and question number 1 is fill in the blanks. We will see which property can exist in these blanks, and the part number 1 is 512 plus 205 is equal to dash plus 512. As we have studied the commutative property of addition, that was if we add some numbers in the left hand side and then change their positions in the right hand side, the answer would not be changed. So here is same. Students, as we can see here, the numbers on the left hand side are 512 and 205, and on the right hand side the number is 512. Here is just missing 205, and we can see that both will have the same answers. Part number 2 is 5430 plus 0 is equal to dash. As we can see here, by adding 0 the value remains unchanged and the answer would be itself the number. So the answer is 5430, and this shows the property of additive identity. Part number 3 is 54 plus 36 plus 40 is equal to 54 plus dash plus 40. We can see that by changing their grouping, the values would not be changed. So here the group was 30 plus 40, and here the group is 54 plus 36, and 40 is already present here. 36 I am writing here. Now the both of these left hand side and right hand side values will be same, and also their answers would be same. Students, let's move towards the question number 2, that is state whether the following are true or false. Part number 1 is the sum of two even whole numbers is even. As we have already studied that if we add two even whole numbers, then the result is also an even whole number. So this statement is true. Part number 2 is the sum of two odd whole numbers is odd. So if we think any two odd numbers like 3 plus 5 and then add the numbers 3 plus 5, the answer would be 8, that is even. So we can say that the sum of two odd whole numbers is not odd, it is even. So this statement is false. Part number 3 is the sum of one even and one odd whole number is even. As we know that the sum of one even and one odd whole number is not an even number, so this statement is false. I am writing here F. Question number 3 is find the differences between the largest odd number of 3 digits and the smallest even number of 3 digits. And the solution is the largest odd number 3 digit is equal to 999. The smallest even number 3 digit is equal to 100. So the difference between largest odd number and the smallest even number of 3 digits, as we can see here, 999 minus 100, and the answer is 899. This is the difference of largest odd number and smallest even number. Now move towards the question number 4, that is state whether the following are true or false. And part number 1 is 8 minus 4 minus 2 is equal to 8 minus 4 minus 2. Their brackets are changed and the elements in the brackets are also changed because the grouping in both of the left hand side and right hand side is changed. So let's solve, and then we would clearly understood either the statement is true or false. Students, we can see here 8 minus 4 minus 2, the result is 2, and then 8 minus 2 is equal to 6. In the right hand side, 8 minus 4 is equal to 4 and minus 2 as it is. 4 minus 2 is equal to 2, and we can see that 6 does not equals to 2. So this statement is false. Now move towards the part number 2, that is 10 minus 6 minus 4 is equal to 10 minus 6 minus 4. Here is also the changing is just in the grouping. So 10 is as it is, minus 6 minus 4, the answer is 2. By solving 10 minus 2, the answer is 8. 10 minus 6 minus 4, we can see that 10 minus 6 is equal to 4 and also minus 4 as it is. By solving 4 minus 4, the answer is 0. So A does not equals to 0. This statement is also false. Part number 3 is 10 minus 6 minus 4 is equal to 10 minus 6 plus 4. 10 is as it is, and by solving 6 minus 4, the answer is 2. 10 minus 2 is equal to 8. Now on the right hand side, 10 minus 6 is equal to 4 and plus 4 as it is. By solving this, the answer is 8. We can see that 8 is equal to 8. So this statement is true. Part number 4 is 15 minus 12 is equal to 3 and 12 minus 15 is not equals to 3. In fact, it is minus 3. So 3 does not equals to minus 3. This statement is false. As we have solved this part, so I have mentioned true false just above them. In the part 1, the statement is false. Part 2, the statement is also false. In part 3, we have solved this part also and the solution is correct. So this statement is true, and in part 4 this statement is wrong. The answer was not equal, so I write here false. Okay students, understood the concepts and tricks and also solve exercise 2b question number 1 to 3 and 4. Allah Hafiz.